welcome to another episode of the ResearchWorks podcast. Hi, Dana.
Hello, Ash. I love that you're here again.
I love that you're here.
So good. It's so great.
It's great. And you know what I love even more than you being here?
What's that?
Having a guest in the studio with us today.
It's so much fun, isn't it?
Doesn't happen very often.
No, it doesn't.
Which, you know, is a privilege because we get to speak to people all over the world. But today we have
in
someone
person.
From our very own backyard.
I love that. So welcome, Associate Professor Ewan Cameron. Hello and welcome.
Good morning, both, and thank you for having me on.
Thank you for joining us, Ewan, and giving up time out of your very busy schedule. Mm-hmm. Ewan is the Director of Malaria Risk Stratification at the Kids Research Institute in Australia, with over a decade of international research experience spanning the fields of astronomy, statistics, machine learning and epidemiology. Dr. Ewan Cameron returned to Australia in February 2020 as an Associate Professor at Curtin University and Honorary Research Associate at the Kids Research Institute Australia. Within the Malaria Atlas Project, he leads a team responsible for the innovation of novel approaches to probabilistic disease mapping with a focus on bespoke model development for sub-national risk stratification.
Well said. Very good.
Big curly words in there.
Big words. Yeah.
So I'm sure based on all of that, our listeners have guessed that, you know, we want to pick Ewan's brains about innovation and direction of statistical methods, which we are definitely going to do today, Ewan. But before we do that, we like to get to know people a bit more informally. So we do that with our icebreaker question. And all this talk about data and statistics and had got me thinking about, you know, having to clean data before you get to the point of being able to
do anything with it.
Do anything with it. Yeah. And then it had me wondering, what's the strangest thing you've ever found while you've been cleaning? Doesn't have to be cleaning data, although maybe the story relates to data, but just cleaning in general.
Yeah, that's a good question. Guess first.
Well, that's quite a question.
It's a good one.
I would say I'm very familiar with cleaning because I lived for a year in Switzerland. And you must understand the Swiss are very big cleaners of everything, particularly when you have a landlord come for a rental inspection. This might be apocryphal, but I have heard tales of them bringing like a dental mirror to look behind radiators and under crevices and things.
Wow,
so,
that's pretty detailed.
Yeah, we were always cleaning very well before our landlord would come around.
I can imagine.
So, yeah, I've done a lot of cleaning. As far as the strangest thing that I've ever found, well, there was a weird and puzzling and almost ghostly experience we had back in the UK. So when we were living in Whitney, my wife and I were cleaning the house and we found essentially this piece of woman's clothing. That sounds like it's going to be a bad story, but it was a like something like a camisole or something that looked like it would have been worn in maybe the 1920s or the 1950s. But it wasn't sort of like underneath the floorboards or sort of up a chimney or something. It was amongst our belongings. And so we were just like, what is this? How did it get in the house? You know, we were like, did a bird somehow fly it? And then it, like, we just couldn't come up with a possible way that it arrived in there.
Oh, wow.
So that's probably the strangest thing I found.
Isn't it?
Yeah. It was
Was it a really old house?
It was, yeah. It was a sort of Edwardian era house, and it had lots of people live in it.
None of them obviously did a great job with the cleaning.
Exactly,
Whoa, that's a great answer.
It really is.
Makes you think a lot. What did you do with it?
I can't remember. I think we eventually just threw it away.
Just get it out of the house.
Thinking maybe if it is cursed or
you don't want,
you don't want
that juju in there.
Exactly.
That's right. Oh, I can't follow up with that one at all because mine was very boring. The minute you said that, I went straight. I didn't go to data clean. I went to cleaning, and I just remember, you know, those mixed lollies that you get, and you get the ones with the teeth.
Yes.
The teeth lollies.
Yes.
And they don't taste good. They look like teeth, but they're just there. They're white. There's no taste to it. Novelty, yeah. So when I was cleaning I must have been behind a couch or something where it's pretty dusty, I found one of those teeth. And because it was quite old and crunchy, it looked like real dentures.
Oh.
That was pretty gross.
Also unnerving.
Yeah, not so great. It would have been some kid going, I don't like this one.
Yuck.
Peg it.
Yep. And it just made you think of dentures. So, that was a bit gross.
Yeah.
So that was probably the weirdest thing I found. Yeah.
So
I wonder where these come from. I like it.
So I've got family who live over in New South Wales in Australia. And they had a really old block of apartments that they bought and turned into like one house. So we were all out the back of this apartment block helping clean the yard. We were getting ready for them to do some landscaping out there. And I'm raking and I'd hear this really weird noise and I look down and there's this massive, like really antique ring with a massive gemstone in it. Oh. And so we picked it up and my auntie took it and cleaned it up and got it valued. And it turned out it was this really valuable antique ring that was just in the dirt in the back of the house. Yeah.
Stuff you dream of.
Right?
Yeah.
I was like, finder's fee, come on.
Yeah, that's right. Oh, that is so cool.
She kept it, yeah. It's it's a very precious.
She kept it, she hasn't sold it.
No. So she's held on to it as kind of a memento of the house because they don't live there anymore. So
that is really cool.
I always wondered what the story behind it was, how did it end up there? A bit like your camisole.
Oh, wow.
But you always wonder the history of things when you stumble across finds like that.
Yeah. And it's like in Australia, we don't tend to have like really old homes, but whenever you do go to Europe and you go to the really, everything's just at least 100 years old.
Yeah.
You do wonder like who's been through there and any famous writers when you're in Paris and things that they might do. And you're like, oh, come on, let's look it up.
And did they sit next to this window?
Yes. I love that. It's really cool.
Yeah.
Me too.
I think one thing we miss here is that sort of blue plaque system they have in the UK where in front of some of the famous houses, they'll say, this was the house that was written about in Sherlock Holmes, or, this is where Benjamin Franklin lived when he was in London. We don't have so many of those things here.
Great history. I love that.
Yeah.
It's really cool.
Okay.
Well, let's get into it.
I know. I could talk about that for ages.
There's lots to chat about.
So Ewan, there's lots we want to cover today, but I think what's really interesting before that is your background and how you came to kind of end up in the area that you are in now. We spoke in the intro about all the different fields that you have experience with. So, astronomy, statistics, machine learning, epidemiology. Could you kind of talk us through that journey and how you've acquired all these different skills and interests? Yeah.
So I guess it begins with university. Or I could really begin with very early childhood.
Yeah.
If I make that a very brief story, I was always interested in science. So when I was about, in year 1 or 2, I started a mineral club with some of my friends where we wanted to be like rock hunters and geologists.
That's cool.
So I was always really into science. But when I went to university, I studied physics and mathematics. And during that time, which was actually at ANU in Canberra, we had a really good astronomy professor who taught introduction to astronomy. And he kind of put the astronomy bug into us and got a lot of us interested in astronomy. Yeah. So that's what I decided to do my PhD on.
Wow. Wow.
And so I did my PhD looking at the way galaxies evolve through time. So when we look back into the distant universe, we're effectively looking back in time because light can only travel at a certain speed. So the light that we're seeing from galaxies which are really far away is light that was emitted many billions of years ago in some cases. So, what you can do is you can look at very distant galaxies, which are galaxies as they were a long time ago, and compare them to more nearby galaxies, which are ones sort of as they are more or less in the present day. And by doing what turns out to be statistics, and I didn't really appreciate that at the time that it was going to be so statistically focused, but by doing statistics, you can try to work out the way that galaxies change over time.
Yep.
And so in doing that, I had to sort of upskill a bit in statistics. And gradually I kind of found that the part of the job that I enjoyed the most was the statistical analysis, learning the different methods and trying to understand that side of the business. And so that's why I made the move into kind of, improving my statistical skills.
Yeah.
And so it was about 2009 when I thought, I had to make a decision. Did I want to stay in astronomy or did I want to try to move more formally into statistics? And I was lucky that I found a position had opened up as a postdoctoral researcher in statistics at the Queensland University of Technology.
Okay.
And so there was a lot of applicants for that position, but the vast majority of them turned out to be people who were fleeing the financial services sector because it was shortly after the financial crisis.
Right, of course.
And
Time it was, yes.
yeah, the professor who was interviewing for the position just had enough of people who'd been trained in stats, kind of gone into the dark side and then wanted to come back. And he said, I'll give somebody new a shot. So it was a bit good timing on my part.
Wow.
So I was able to go into that position and sort of upskill in statistics and really learn a lot more about modern techniques that they hadn't learnt in astronomy.
Wow. Just goes to show how much a career can evolve over time, right? And, something that we talk about a lot often, what you start out doing isn't necessarily where you end up at the end of your, or even, halfway through a career, but all those skills that you learn along the way just help evolve your understanding of, the things that you're really passionate about and interested in. And you can take that in so many different directions, right?
Yeah, I definitely think it sort of shows that when you're, say, studying at university or even still when you're in high school, like having that a diversity of different subjects to take on is really an advantage. I know, like, for example, in the UK, they specialize very early in their A levels. So in high school, you can really specialize to just say, I'm only a science guy, or I'm, I'm only a maths guy, and focus very heavily in one way or the other. Whereas here, when you do year 12, you generally have still quite a mix of different subjects. I think there's something to be said for that because, you might not discover your passion, as a high school student or as an early university student. It might be quite later that you find what's the real thing that you're interested in.
Yeah. For sure.
I love that. And then being able to follow your passion is always, we talk about that a lot, because when you're passionate about something, you're just more curious. You want to know why. And science is all about trying to figure out the why part of it. And that's the fun part. And the way that you approach it, I love that we're so diverse in the way we think about that, because we can't answer big research questions on our own. There's not enough skill to do all of that, right?
And why would you want to, right?
No way. And, I think that's how I got to know you, Ewan, is just through some research that, we're part of. And then it's like, actually, I don't know anything about this. And it's like, hey, how would you solve this? And it's just another perspective, another view. And that's what makes this area so cool. Now, how I sort of first heard about you was through the work that you do through the Malaria Atlas Project, which the stuff that I've heard you guys do is pretty cool. Can you tell us more about what that is? I mean, that was part of the move that came to Australia, for you to come back to Australia again.
That's right.
Do you mind giving us a bit of a history of that and sort of what this project actually is?
Yeah, absolutely. So the Malaria Atlas Project was started in about 2006 by Professor Simon Hay and Professor Bob Snow from the University of Oxford. And at that time, the way the malaria funding landscape and global malaria policy landscape looked was that there had been a lot of work on malaria eradication through the 50s and 60s, and then it stalled and malaria resurged during the 70s and 80s. And so the situation by the early 2000s was that globally there was a huge burden of clinical malaria cases and childhood deaths, which weren't being efficiently and effectively tackled by a coordinated global response. And one of the reasons for that was that there was actually very little precise understanding of where the greatest burden of malaria was. So we knew that, for example, sub-Saharan Africa has much higher malaria burden than, say, Southeast Asia, amongst two different endemic places. But as far as subnational tailoring or even sort of subcontinental tailoring of identifying places to put different interventions, there wasn't much evidence out there to guide the international community. So Simon and Bob's idea was to start a project that would look at gathering all the available quantitative data and sort of measurements about malaria transmission intensity and cases and so on, put them all into one database, and then use statistical methods and sort of modern cartographic methods to make these maps of malaria risk, which then the international community could use to target the delivery of bed nets or anti-malarials and so on, and make sure that they were going to the places where they would have the most impact.
It's very cool.
It is.
Especially when you consider like the how big the problem was, really,
Yes.
and therefore how you're going to actually tackle it by looking at where you can direct your resources in the best possible way. That was really sort of the idea behind it all, wasn't it, to be able to identify these areas. And that's where the first time when I read about it, like I'd never even heard about it before, but, geospatial methods.
Yes.
It was the first time I heard anyone talk about it. And that was something that you guys are really well known for, isn't it?
Yeah, it is. So there's a few different sides of the business. So the side that I kind of came into bringing some expertise I had before I joined the project was the statistical side. So one thing we do is we use these statistical methods which specifically acknowledge the spatial aspect of the data that we have. The sort of briefest way to explain what they do is that they suppose that in the absence of anything else to tell you otherwise, two nearby locations are most likely going to have a more similar malaria risk than two distant locations. It's kind of a sort of simple rule of thumb. Sometimes they call that Tobler's first law of geography, which I think is just that nearby places are more similar than not nearby places.
That makes sense. I can get my head around that.
So the statistical methods that I use, they sort of implement that law in a more sophisticated way and try to represent the uncertainties that we have about we're trying to guess at what malaria risk might look like at places that we don't have data from using data that we do have from places nearby to those places. So that's one side of the techniques. But then there's also a huge part of the team that works on aspects of sort of modern geographical science and digital geography. So these different tools that they have for representing landscapes and environments with satellite-based observations and also data from things like Google Maps or Google Roads, OpenStreetMap. And putting all of that digital data together to inform our risk maps and policy.
Wow. And this is probably quite a naive question, but does that are you linking that with health data to try and, I suppose, track the burden of disease in a specific area at any given time?
Yep, absolutely. So there's two types of malaria data which we mostly work with. The foundation of MAP was looking at prevalence data. So prevalence is just means, in this case, cross-sectional prevalence. So you go to a village as part of a dedicated survey and they might select, say, 30 children, give them all a rapid diagnostic test for malaria, and we get a kind of a snapshot. There might be 10 out of the 30 children are positive for parasites at that moment. But then the other type of data that we've been increasingly using of late is routine case data from malaria clinics. So every year there's millions and millions or hundreds of millions of people having malaria cases and receiving treatment for malarial fevers. And initially, certainly when the Malaria Atlas Project started in the mid-2000s, the quality of data record keeping in a lot of these facilities was very poor. And even still today, a lot of facilities are primarily using sort of paper-based logbooks. And so, if people would call them to gather an estimate of how many malaria cases there were, they might, in the past month, they might just sort of open the logbook, flip through it and kind of thumb guess that there was about maybe 100 cases and very, very kind of inaccurate type of reporting. But there's been a big rollout of digital health, sort of digital electronic record systems in medical facilities across a lot of places which had previously had only paper-based record keeping or no record keeping. So nowadays, actually, we get data kind of not quite in real time, but within a few months of it being gathered on how many cases went to which facilities and where those facilities are, and that can really go into kind of almost real time tracking of malaria burden.
Wow, and I guess the impact, everything you've described there, seems by supporting people in different areas and regions, even just to upskill with regards to how they record the data. What kind of impact do you feel like this whole project has had? I mean, it's been nearly 20 years now.
Yeah.
How would you describe that in your view?
Yeah, I mean, within the global malaria community, it's very hard to sort of overstate the impact that the Malaria Atlas Project has had. Anytime you go to a talk about malaria, almost the first slide that they show will be, something taken from a map, whether it's one of our malaria risk maps for that country or for the region, or one of the other sort of products that we make, estimates of bed net coverage or anti-malarials. So within the research community, I think you can see from things like the citations and that sort of thing.
I did notice that. There's a few papers I'm like, whoa, that was a wild citation numbers.
Yeah, exactly.
Reference.
And they're often picked up for just the most foundational statement that you want to make, like how many malaria cases were there were there in the world last year. That's the reason that they cite the work. So research-wise, massive impact. We're specifically a WHO Global Collaborating Centre. So we've been working with the WHO on producing these estimates in a standardized way, which they kind of agree with, and that's transparent, and that that essentially the WHO feels it can buy into, and that they can and that the countries as well who use those WHO sort of advice can also agree with. So on the policy front, it is having a big impact. Just the ability to track progress has been important.
Yep.
And in particular, one of the things which has emerged over the past 5 years or so is this unfortunate rebound of malaria cases. So there was massive progress made over the period of sort of 2000 to 2015, which coincided with a huge increase in funding, sort of international donor funding for malaria control. But although that funding is at a very high level still, it's plateaued, and unfortunately that's coincided with sort of stalling of progress in terms of reducing cases. And in some countries, there's even been a resurgence of malaria. So it's just one of these really difficult sort of health challenges where we sort of have to be constantly ramping up to force it all the way down. And with the idea being that, we move towards eradication and elimination so that you can then eventually stop having to spend all that money.
Yes. Yeah.
Just shows what's involved and what's needed to be able to make these decisions, where to direct funds, where to highlight risk and health priorities. It's such an important part of
and
what it is that you do.
Funding and resource, having real time as you can kind of get
so much to learn from that.
Yeah.
So much to learn in so many areas.
Yeah.
Like we're talking about one area, but I'm like in my head, I'm really thinking, all the other
so overwhelming,
aspects.
Isn't it?
Yeah. What are we doing? Yeah.
Let alone being involved in it.
I know. That's right.
Ewan, for a lot of our listeners who are clinicians and researchers, I think, probably talk of a lot of these statistical methods and the ways that you might use statistical methods is beyond their scope as, clinicians, and even, some researchers are just beyond what we are capable of.
Beyond my brain.
Good at recognising that and then seeking guidance and support from people like yourself. So we thought it would be great to get your take on some of the methods that you've probably had a lot of experience with but are relatively new to a lot of our listeners and to us.
Yeah.
So we'd love to talk about things like machine learning and artificial intelligence with you and pick your brains on that if that's okay.
Sure.
So let's start with machine learning. What is the role of machine learning in, analysis, and how does it contrast with some of the other statistical methods that we might be more familiar with or more comfortable with using?
I guess there's a couple of schools of thought about what's the relationship between machine learning and statistics. To my mind, I kind of see them as basically the same thing, almost like machine learning is just statistics with fancier offices and maybe better clothes. But
such a good way to describe it.
But I guess maybe one place where they tend to differ is that machine learning is more applicable when you have a larger amount of data. So statistical methods, I guess, are methods which try to take the data that you have and account for the randomness of the data collection and the errors that might have been accumulated in it.
Yep.
And just the fact that you might have only a limited amount of data, say a sample of 10 children, to try to represent a whole population of thousands of children. So you're trying to essentially to extrapolate from a small amount of data to the best possible guess you could make about what the whole of it would look like. And so statistics tends to focus more on that smaller data regime.
Okay.
And machine learning when you have a lot more data, so you have a lot more information to use in your decision-making engine, which is your model. And so they're both working with uncertainty. They're both trying to make guesses about some underlying problem or something like this. But the methods tend to diverge mathematically a bit based on the nature or the size of the data which you're working with.
Okay. If you were to look at, say, so if you're deciding and you've got a large data set, like we're talking thousands of points potentially, machine learning seems to be the way versus statistics. Is there any other circumstances where you might say you've got, I don't know, an average size of data? How would you make a decision to then go, okay, I think this will be better for machine learning? Is it very much based on your question, like predictions versus cause and effect, or, that kind of, what would you say about that? I think I've asked it properly, but you seem to understand what I'm saying.
I think you have. So I guess one thing I should say is when we talk about having a lot of data or a little amount of data, it to some extent it depends on the model that you're trying to fit. So I was saying that I mostly do statistical techniques, but then I had also said that with the Malaria Atlas Project we have a huge amount of data. So the way that in that case we see the data as being small is in regard to the size of our model. So that we have a big model in the sense that we're trying to estimate malaria risk at lots of different locations. So you could sort of almost imagine like every location as being like a free parameter of the model that we're trying to estimate. And so in that case, we have about the same amount of data as we have places that we want to do estimates at. For a lot of problems that you'd encounter, say, I guess in a routine healthcare analysis, you would have a smallish amount of parameters. I think or smallish amount of parameters that you're trying to predict. So you might just be trying to predict, say, the time to clearance of say an infection given a drug. So it's one thing that you're trying to estimate amongst a population which might have a degree of diversity. You might be trying to adjust for gender or for age or some other different characteristics like that. But in general, I think the parameter space is relatively small. So then in that case, you're probably going to be able to work in either the statistical or the machine learning environment because you'll have, if you structure your machine learning model in the right way, you'll have easily enough data relative to the number of parameters that the machine learning method will work very well. But you could also do it with a statistical method. And so in that case, the decision really just comes down to a mix of preferences around the types of software and things that you're comfortable using, and aspects of, I guess, the type of people that you collaborate with. For example, if you have collaborators that have previously used one method or another, then you may as well continue to use the same method because that establishes a sort of a benchmark for the field of how you're doing things, a type of reproducibility. Beyond that, there's some technical reasons why you might prefer one or the other, which are very mathematical. But I think pragmatically, it almost just comes down to individual preference and comfort at that point.
It almost feels sometimes with machine learning, it seems, because it's so new and people are so familiar with statistical methods, whether they do them themselves or not, machine learning almost sounds like this bit of a black box, like don't really know what's happening within that. But if you were to compare, like in that case scenario that you gave there, and you did both machine learning and statistical testing, would the result come out the same way, or would it be presented in the same kind of way?
It would probably come out quite differently and be presented quite differently. So the classical kind of example for a machine learning model, although it might be considered maybe not such a fancy model by machine learners would just be a sort of a random forest. So this is a model which they might use for classification or regression.
Yes.
So you could have your data and you would be predicting that same sort of thing, like say time to clearance of an infection. And the inputs that you would give to your machine learning model would be all the different dimensions of the data that you had on your patient sample. So this is the gender, the height, the weight, the age, but not just a few things, everything that you had measurements on, and you could kind of throw the kitchen sink at it. In that case, the machine learning model would try to look at all of those and find smaller kind of combinations of them that helped kind of guess the time to clearance better than others. And it might come up with something like, it would be a little difficult to plot it out, but it might look like it's found a combination of age plus weight times height, or something that that's a little bit esoteric and hard to interpret. But it might be doing a very good job. And for the purposes of predicting to future patients, then it's going to do that very well.
And it's about predictions, isn't it?
Yeah, exactly.
It's more about predictions than anything else.
Whereas the statistical model, you would tend to structure it a little bit more according to what you believe to be important in the problem. So you might say, okay, we think gender is definitely going to be this dichotomous thing we'll put in there. We think, weight will be something where it's going to be, kind of linearly dependent on weight, and that'll be a kind of a simple thing we'll put in.
More hypothesis-driven in a way.
And limited by, I suppose, the assumptions that you're bringing to that question or problem. Is that right? Like, I think of machine learning as, whether this is correct or not, it kind of evolves based on the more data that are exposed to machine learning algorithms, the more accurate a prediction might become, or easier it might become to predict something.
Yeah, it can certainly adapt itself in complexity. So this example I said, where you might have a certain combination of variables, it might with more data, it might augment that to say, oh, now we're going to sort of have this weight squared now goes into it, or some more complicated things. But with the statistical model, there are other sort of advantages that come with the simplicity, as far as you can sort of, because you can study the model mathematically, it's more, you can study both of them mathematically, but it's more tractable. You can sort of make a lot more theoretical progress. Then you have some kind of more theoretical guarantees about how the statistical model should behave.
That's a really good point.
It's worthwhile talking through, isn't it? Because I feel like it's one of those things that comes up more and more now as more people, I know machine learning has been around for much longer than the public's probably known about it. But it just also sounds that if you've got a lot of data, statistical models might take a little bit longer to come to that place, because you are testing out different scenarios, whereas machine learning in some cases would be quite quick, in the sense if you've got the model correct, you could find something yourself. But you would have to actually look at each case under its own merit and evaluate it that way. It's not like one size fits all, one's for this, one's for that.
I'd say it's like a lot of scientific methods. I know that Richard Feynman's advice is like, in science, the easiest person to fool is yourself.
That's so true.
So, you can fit both of these models, and you're really happy with how the model looks. Like, particularly if it's a statistical model, you fit it and you're like, oh, cool, I found that there's a big difference between men and women, and this is going to lead to a scientific result I can publish. But then, you fit the model. You need to then actually go and kick the tires on it pretty heavily and do different type of testing. So all these kind of things where you hold back a portion of your data, fit the remainder, and then see how the predictions do to that portion you held out. Those kind of things, you have to do them for both the machine learning and the statistical model. And do those carefully and make sure that it is actually doing something sensible.
That's a good point.
I feel like there's an explosion of electronic health data at the moment, here in WA, but, globally as well. And we have access to more data than we kind of ever have before. So I suppose, do you have any advice for researchers and health professionals, other than seeking the support and guidance of someone like yourself, which, I think absolutely should happen with big electronic health data sets. But any advice on how to deal with data in that way? And if you're starting from scratch, what are the kinds of things that you need to think about? before you embark on, interrogating that data or asking questions of it?
Yeah. I guess it's very hard to make a general prescription.
Yeah.
Maybe the best thing that you can sort of say on that topic is that you really want to think about it in terms of a scientific question. So I have said that the machine learning models can be black boxes in a sense, but even if you're going to go down the path of using a machine learning model, you're going to want to make sure that you're giving that model data that you reasonably believe it makes sense as something that you want to predict on.
Yeah, sure.
So you are collecting data and you're going to do an analysis. You have to think of it in terms of the logical system of what's going on. One thing that I find is very helpful for that is drawing these things called path diagrams or graphical models. So
we like a graphic.
Yes, I can follow those ones.
So for people who don't know, that's a model where you draw the different variables you think influence the system. So you write down things like gender, age, weight, and then the outcome that you're looking at, say time to clearance, and then maybe some variables around the drugs that you're testing, those kind of things. And you draw arrows between the different variables you've written down in terms of the relation that describes the relationship of how you think one influences the other.
Yeah.
So if you think that mass, sorry, did I say mass? I meant patient's weight. As a physicist.
I was going to say, throw back to your physics background.
That's right.
Absolutely, yeah. No, I meant to say weight. So if you think patient's weight is something that influences time to clearance, you draw a line from weight to time to clearance. But then you might also draw a line from age to weight. So you need to recognize that, that age is going to affect weight? And and then you might say to yourself, does age affect time to clearance in a way which is other than its effect on weight? And then you decide whether you draw a line from age to time to clearance. And so making that sort of graphical model, and even maybe you don't come up with one single model, you might come up with a variety of models that'll help you see what your assumptions about the system are, and then also what you simply don't know about the system. If you can't sort of in advance decide between two graphical models, it probably indicates there's a place where you either need to do more research, gather more data, or kind of rethink the question.
Yeah. I think that's great advice because you can collect everything and anything these days, right? You've got to be very careful.
That's the risk, isn't it?
That is,
that you kind of end up down a rabbit hole of asking questions or incorporating variables that don't necessarily make, if you come back to a logic model or a graphical model, putting it down on paper, does that actually make sense?
Yeah. It comes back down to even just being really simplistic, the definition of evidence-based practice, right? It's like getting the scientific, empirical data that's been studied, your clinical knowledge, what the needs of the consumers are, to actually look at the outcomes that are important. And as a clinician going, okay, what makes sense? What do I see? And making an informed decision about what that might be first, rather than just to go, I'll just collect everything just because I can. Because then you get missing data and you have to deal with missing data. And then that's a whole thing in itself.
And potentially a lot of redundant data. You didn't really need to collect.
You don't have to keep, someone has to clean that.
And I suppose there's also, the risk of it becoming a bit of a fishing expedition, right? You can probably find any answer that you're looking for if you tested enough different ways,
absolutely.
So being really clear from the start about what your question, what question you are trying to answer is really important.
In statistics, that sort of that type of thing you could call a fishing expedition is often called the garden of forking paths. So you go down a research study and then
much more eloquent.
You notice it's the initial result doesn't not quite how we expected, but then if I divide the sample up this way or I test something slightly different, now I'm getting something significant, and then somehow, because again, you're the easiest person to fool yourself, you say, actually, I think that's what I thought all along. And
that's so true.
I'm going to have to remember that.
That's a really good one. Like how you say that. So now a question about AI, which I feel like sometimes AI and machine learning sort of go together. But, we're seeing more of it. The general public's hearing more about it, this new models and different versions coming out all the time. So I guess my question for you is, what can we use now and what do we need to be careful of what's currently available? And, the background for this is often people using like ChatGPT, for example, to do some testing or whatever it might look like for some help. What would your advice there be?
I guess I would just make quickly the distinction between AI and machine learning.
Yes, good idea.
Traditionally, those have been kind of grouped together, but I think there is a reasonable separation of them in terms of the AI doing something that in a way reproduces a function of the human mind or human body. So particularly robotic vision or computer vision. So for self-driving cars and that kind of thing. I think that's very much an AI type of thing.
Yeah.
But then also the large language models, the ChatGPTs, is very much in the AI camp.
Yes.
For ChatGPT, I've tried, for example, putting like a malaria mapping question into ChatGPT, and actually it does very well. You can say to ChatGPT, could you please make a model which will predict malaria across Ghana or something like this?
Yeah.
And it will actually write you code, which looks very much like the code I would write. And it sources data actually sometimes from the Malaria Atlas Project website. But it downloads the data and it can do everything that would get you like kind of to a first order type of model.
Yeah.
So it's very impressive. I certainly think that they've come a very long way with the way those type of models work, and there's a lot to be said as far as that as like a technical achievement. Of course, I think with these AI models, it's very easy to get a result, but if you haven't understood what's going on, you just don't have that capacity to kind of kick the tires on it and make sure that it hasn't kind of come unstuck somewhere.
Yes, that's so true. Yeah.
So I think that they're very powerful for model building, but without the user understanding things deeply, it's very easy to go wrong. There are fantastic things that AI can do as far as the data cleaning. So we mentioned cleaning at the start.
I'm interested.
I think there's huge potential. One thing we've found is, for example, if you get data provided in the form of addresses from different people, often that will come in a whole variety of ways that it's written down. There's no like one single standardized way to write an address.
Yes.
But you can ask AI to basically go, or you can ask ChatGPT through code to go look at all your data which refers to addresses and look through like different Excel spreadsheets and figure out which column is referring to street names, which column is referring to house numbers. It doesn't need to see a label at the top that's in a standardized form, like this is the house number.
Yeah.
It just knows what addresses look like, what house numbers look like. It'll do all of that, and it'll standardize your addresses and then attach them to or match them to a database of addresses that you have.
Saves a lot of time.
Yeah, you can imagine how time saving that is.
Absolutely.
So for a lot of those data cleaning tasks, I think it's fantastic. More generally, as far as AI for things like teaching or composition, like to read a book written by AI or to hear a lecture written by AI, I'm personally not very comfortable with any of that sort of stuff. And that kind of thing moderately horrifies me. But for certain jobs in a limited scope, I think there's a massive potential of AI to improve the way research is done and make it faster.
I think for the ease and the time-saving component, but I completely hear what you're saying and agree that it can help you if you understand it. You never want to negate that element of it, because
you don't know
if
what
you have to stand up and defend it, you don't go, well, I'd put this through ChatGPT. Like, that's not enough, right? No. So you need to understand your data and at least have those theoretical backgrounds. But the great facilitator. I'm all for saving time. Because doing those things like line by line,
soul destroying,
by hand, they make you question why you do any of this in the first place. So I'm all for that to help me.
And I think as humans, like there is a really clear distinction between the type of work which is enjoyable and sort of mentally satisfying, good for the soul, versus the type of work which is horrible and you'd like a robot to do it.
That's right.
Absolutely. So given all of that, Ewan, what would you say would be, I suppose, the key basic skills that clinicians and researchers should have, before we start dabbling in ChatGPT and all these kinds of things, what do we need as a foundation to have before we enter into that arena?
I guess two things. First would be basic mathematical literacy. I think rather than spending a lot of time focusing on very detailed aspects of something that even I find quite boring, like for example, a lot of time is often spent in statistics courses learning about the quantiles of the normal distribution.
Yes, so
like
much
really
time.
going into to tables and Z-tests and T-tests and things. Some of that time could be spent working more on basic mathematics. So really just getting that introductory familiarity with things like calculus and integration, which often people would either never see or just dabble very briefly with at the start of university.
Okay.
Those sort of things, even simple things like, well, not simple, but things like set theory and algebra. I think you can actually learn a small amount of them, and it's very beneficial for understanding mathematical methods and feeling literate, without trying to become an expert in set theory or algebra.
I would have to say, as when I left high school, I never thought I'd use it again.
No.
But when I'm trying to work things out and work out relationships, and you think about it in the reverse way, like clinically, this is what I'm seeing, you write it out, you do use it.
Yeah.
I feel like going back to my younger self and say, look, you do need to use this skill. I know you said you wouldn't, but you do.
Well, it shows the power of context, right?
It
You've
really
found
does.
an area that you're passionate about applying it in, and so you're able to do that much.
That's right. Yeah.
Yeah.
When I have the
Much more
equal signs
effectively.
there, and I know I need to make them both sides. What do I need to do to both sides? Like just knowing that helps me to work out. I'm like, oh, that is A equals this. Oh, that's what I need to do.
Yeah.
So that's a good point. Yeah.
So that was the first thing I said. The second thing I was going to say is programming, just a small amount of programming skill, I think.
Okay.
It doesn't have to be, foundational programming where you go and learn about C++ or Java or something like that. But programming in a higher level language, like in R or Python or something like that, where you can just learn how to read in tables, select columns, make plots, and do some mathematical operations.
Yes.
I think that's very beneficial.
Yeah.
Definitely.
It's a good area to prioritize. Upskilling in, isn't it?
Yeah.
Yeah. Yeah. And it's the way of the world moving forward.
Yeah.
You do need to have those skills.
Yeah. And there is lots of support through organisations, but also online as well to upskill in those areas. You know, there's particularly for R, there's lots of tutorials online that you can access, and you can kind of really tailor it to the specific thing that you're trying to work through. There's always, YouTube videos and things like that you can watch
pop up a lot.
that are really helpful in that area.
Yeah.
It's really cool.
So you're looking forward, what kind of emerging trends or techniques in statistics and machine learning do you think will have the greatest impact when we're talking about solving real world problems? Because at the end of the day, in health research, that's what we're about, solving real world problems. So I'd love to get your take on kind of where you see this field going and how we can apply all these amazing things that are evolving in this space to real world problems to have an impact.
Well, one of the areas that I've been working on a little bit over the past few years, and I haven't kind of come to any great expertise in it, but I've been struggling with it and trying to upskill in it, is the field of causal inference. So it's a branch of statistics that focuses on trying to estimate causal effects as opposed to just simply predict outcomes. So this is, when you do a randomized control trial or an actual experiment, that's sort of the gold standard way for trying to measure a cause and effect, where you really take all of that, the variables which can confound your observations, so the factors which might influence both the decision to take a treatment and the outcome of the treatment in the real world. You take those out of the picture by the randomization, and so you simply have this sort of matched group of patients, one receiving the intervention and the others not receiving it. Of course, there are a lot of circumstances where it's not reasonable to have a non-intervention group. For example, if you have a lot of patients with malaria, we can't treat one group and then not treat another group.
That's right, yeah.
So then, you have to go and find, okay, what's the current standard of care versus the improved care? But even then, there's a lot you'd like to know about what would happen if somebody didn't get an anti-malarial, because a lot of people are not getting anti-malarials in the real world.
Okay.
So there's effectively experiments, if you like, that you'd like to be able to do. You'd like to be able to sort of understand precisely what happens with this strain of malaria when somebody's not treated. But you're not going to do that in the real world. So you want to take observational data that you have, so information about patients, the that turn up to hospital very late versus patients who turned up kind of early in their infection. Use these different sort of opportunistic data sources, and then do a statistical experiment that replicates the effect of as if you had done a randomized control trial.
Wow!
So you use kind of mathematical adjustments to simulate that effect of randomization within an observational sample and get to your result.
That's pretty cool.
I want that.
Yeah.
Okay. So you're on your journey for that, or you're doing that sort of work now?
I'm currently working on a method called the proximal causal method, which is a method where you have some hidden confounder. So this thing which mixes up the assignment of treatment and the outcome of the treatment.
Wow.
And you have sort of proxies for it, which you can kind of balance against each other and try to use to simulate a randomized control trial.
Amazing.
So great. I have no words. That is so wonderful.
Yeah.
And I think this conversation has been just so great to be able to go into this in detail, because we often don't get this opportunity to talk about this level, because I don't know, when we look at the big problems, big data sets, what do you do with it? And you want to be able to combine forces of different research teams, for example, and come together for that. Otherwise, we're all doing our little bits in different countries, and sometimes coming to that overall, we could do it, but it's logistically difficult. But I think statistics offers so much in terms of the future of it.
Definitely.
Yeah, amazing.
And just, highlights how having, multidisciplinary teams.
100%.
We talk about it clinically, but I think, in the research space as well, it's so vital that we all are bringing different expertise and experiences to help.
Just a fresh look on things.
Yeah.
Love it.
Really tackle those big problems.
Well, we're not done yet. That's what I'm very curious about, because this feels a lot more up Ed's alley. But let's see how we go in this one.
Okay.
Let's head to Tell It to Ed. Ed, as you know, is our producer. He doesn't have a background in child health. But he has been listening to this conversation. He's got his computer open. I don't know what he's going to ask about this one. But before Ed asks you a question, I'm going to get you, Ewan, to summarise what we've just spoken about in about 60 seconds or so. That feels really hard. And Ed will have time for one question. All right, take it away, Ewan.
All right. The work that I'm doing is working on understanding problems in child health, particularly malaria, but then some other types of child health issues, through statistical modeling, focusing on things, on data that vary through space. So we're bringing location into our statistical models to make maps that help disease modelers figure out where the hotspots of disease are, and it helps policymakers figure out where to go and put interventions to have their biggest impact.
That was brilliant. That was
really challenge accepted,
right?
and
You just did it and
nailed.
snapped. That was amazing.
There you go, Ed.
Right, Ed, over to you.
Thank you. So we've been around nearly 200 episodes, and this is probably the first one where I've felt comfortable with the explanations that have been going on. So
It's in your wheelhouse, Ed.
I'm feeling quite comfortable. And a little bit like Ewan said, I do advocate for people learning more mathematical skills. I think that it's actually pretty important in general life. And it's always really beneficial, and programming is also really important given the world we live in. For context, I've been doing programming for a little bit, started off doing some mobile apps and was even involved in building like a 3D video game engine, and now I've kind of found myself doing a little bit of machine learning.
Ed's found a friend.
But I'm going to be a little bit naughty with my question. So, with everything that we've just spoken about, here's my question. Are statisticians, in the traditional sense, now an endangered species? And I mean this in the sense that...
It's a great question, though.
If you don't have experience with machine learning or models or programming languages, even simple ones like Python, the libraries like scikit and PyTorch and all those sorts of things, then as a statistician, I'm assuming that you wouldn't be as efficient in data processing, pre-processing or cleaning, or even imputation of values and data, or using things like mice. Like, that would be very time-consuming, and I just would think that might not be part of the traditional skill set. So, and large language models like ChatGPT are obviously making it easy for people to dabble in it, but perhaps there's also a risk there that it becomes even more black box to some of the people who are using those tools in a professional way?
Yeah, that's a very good question. I think that maybe a few years ago that would have been even more controversial than it is now.
Yeah.
I think statisticians have realized that the different tools which we call machine learning have really revolutionized the type of things that you can do with data. Mm-hmm. So I think that now, although that wasn't the case maybe going back 5 or 10 years, almost every statistics course or program would have a large component of what you would recognize as data science and machine learning. Mm-hmm. And so as far as teaching students, I think the statistics departments around the world have really got on board with machine learning. Mm.
Okay.
But as far as statisticians, though, becoming an endangered species, I think that's very interesting. So when I think of a statistician as in an academic mathematical statistician, I tend to think of somebody who's worked for 20, 30 years or longer on a very specific problem, which looks like a relatively simple model these days, compared to a machine learning model. So it might just be like one person spends all their time looking at linear regression, simple linear regression with only a few variables, and going really deep into the mathematics of that and understanding that at a deep level. I think there is still a need for people to do that sort of work. So to focus on what we consider more of the domain of statistical models than machine learning models, the more simplified versions, because the lessons from the simple case do generally translate in some way to the more complicated machine learning models. And so, I think the statisticians, as in people doing that intense mathematical work on one particular simple focused model, I don't think they're really an endangered species, but I think to maintain their relevance in the sort of kind of academic funding and sort of interaction space, I think they have to be able to relate what they do to machine learning and to data science. And I think a lot of statisticians have done that very successfully. So, I think, we're not really an endangered species, but we might need to do a better job at explaining to people why we shouldn't be kind of put out to pasture or something like that.
Okay.
That was a great question.
It's very diplomatic, but a good answer.
Really good one.
A good answer.
Yeah.
Answered that beautifully.
You did. Well done, Ed. That was a good question, and I'm glad that you were able to, follow along for this one. To all of our listeners, I hope you really enjoyed that as much as we did. Not only was that just so thought-provoking, I think it really makes us think about the future for where we're headed in terms of research.
Yes.
So look, we'll put links so you can see what Ewan does on our website, researchworks.net. And of course, there's a CPD form there that you can fill out as well to keep this as part of your record of your PD requirements. Yeah. But for now, we'll say thank you once again, Ewan. Thanks for coming in.
Yeah.
Thanks for having me on the show.
It was so great.
You took some really complex topics and broke them down for us in a really friendly way. So thank you for that.
Yeah, really, really beautiful. So to all of our listeners, we'll talk to you all again very soon. So goodbye for now.
Bye.